Hi everyone. In this lecture, we're going to talk about TCP and UDP connections to enable us to send data back and forth from a server and client application. And this lecture is going to extend the previous lecture where we set up a socket to connect a client and a server. So just to recap on the first lecture, we set up the first 5 steps for the server application, from loading the DLL in the first step, and then creating the socket, and then binding the socket to the IP address and the port number of the machine, and then using that socket to listen out for connections. And then once a connection request came from the client, we then accepted that and we connected with the client. And then on the client side, we followed the first 2 steps. Those are shared between the server and the client, initializing the WSA startup, loading the DLL, and then creating the socket at the client end. Remember, we had a dedicated socket for the server and one for the client. Then rather than having to bind the IP and port number to the socket of the client, that happened automatically in the connect function, where that's bound automatically and allocated automatically by the client machine. But what we could do is we could specify the IP and the port number that we wanted to connect to, meaning that we could specify the server details that we want to connect to, which is at the server end that's listening out for requests to come in to connect to that IP and port number of the server. Okay, so that's where we got to in part 1. If you want a more fuller discussion of that, please go back and watch the first lecture on network programming and creating the sockets. But assuming that you've watched that and set up the first 5 steps on the server application and the first 3 steps on the client application, what we're going to do in this lecture is we're going to talk about step 6 of the server and step 4 of the client, where we send and receive data. And we're going to have a look at 2 different approaches for transmitting data. So we're going to start by having a look at the TCP method of passing data back and forth from server and client, transmission control protocol. And then in the second half of this lecture, part 2, we're going to look at UDP, user datagram protocol. Okay, which differs in its approach. So let's start by having a look at TCP. And just remember that we already configured the creation of the socket to use TCP. We specified that in the parameters of the socket function. So if we use the code from last week, we don't have to change the creation of the socket, nor do we have to change the binding of the IP and port number of the machine to that socket. And this is important to transferring our data via the TCP protocol, because TCP requires a connection to be established. Okay, it will only send data through a socket that connects both a client and a server, which differs to UDP, where this information of the IP and the port number that we want to send data to is specified in the sendto function of UDP. This isn't configured beforehand, so we don't have to establish a connection between 2 computers to be able to send data. With TCP we do, and it's sent via a dedicated socket which has established the connection. But with UDP, this connection doesn't need to be established. Okay, so just worth knowing that before we have a look at sending data. We'll come on to have a look at UDP in the second half, but just know that we've already configured the creation of the socket and the binding of the socket from last week to use TCP. So we can move straight on to step 6 of the server and step 4 of the client, where we can use the send function to send data. And this send function is going to take 4 different parameters. First of all, it's going to take the socket. So this will be the accepted socket in our practicals, the one which was returned from the accept function of the server. And this is the one which is dedicated to the connection between client and server to enable the original socket to continue listening for any new connections that may be coming in. That's not going to take place in our example, but still this would enable the 2 processes to take place concurrently. But anyway, that's what the first parameter refers to, the connected socket, where the connection between the two computers has been established. And then for the second parameter here, we have a pointer to a char array of characters. It's going to be constant as well, so we can't modify it. And this is going to hold the message, essentially the data that we want to send to the other machine, the client, or if we're on the client, send to the server. It's going to work both ways. And so we'll see in a moment, we'll have to set up a character array which will hold this message that we want to pass. And so then we pass the pointer to that message and pass it to this parameter. And then as this is a primitive type, we don't have a attribute that refers to the size. In the third parameter here of the send function, we have to pass the length of this array. So this will just be the number of elements that we've set up, the number of individual characters that we could send, or size of the array, basically. All right, so that's the third parameter. And then fourth parameter, we have a integer for flags. And we're not going to change any of these. We'll just accept the default settings. We are going to accept the default behavior. We're not going to play around with any of that. So we're just going to pass 0 there. But optionally, we could pass in certain values corresponding to different behaviors that we may want the send and receive functions to respond to. Okay, so all going well. If we've set things up correctly, we will pass our specified message through the socket to the machine at the receiving end. So we're going to use the send function to send data from the server to the client, and also vice versa from the client back to the server. All right, so we can use the send function at both ends, both at the client end and the server end. Okay, and this send function, like usual, will return a value to affirm whether the operation was successful or not. Now, in the past, with the functions that we used for the initial stages, creating the socket, binding the socket, listening, those returned 0 values to confirm that the operation was successful. But here, this send function is going to return the number of bytes that were sent in this function. Okay, so ideally, we want a non-zero value this time around. Okay, so just remember that difference. With these send and receive functions, we want non-zero values to prove that they were successful. It specifies how much data was sent and received. Whereas for the initial stages, we want 0 values to confirm that it was successful in setting up the socket. All right, so just remember that it's been flipped for these functions. Okay, and if the send function returns a 0 value or a value corresponding with the constant socket error, we can assume that it wasn't successful in sending data through the socket to the receiving end. Okay, so let's have a look at a code example now where we'll see this in action. All right, so here on this slide, we've set up a character array. We called it buffer. Specified it to have 200 elements, so that will range from 0 to 199, where every element corresponds to a single letter, digit, or symbol. And then in the next 2 lines, you'll notice that we're using some alternate functions to cin and cout. We usually use cout to print messages to the screen, but here we're using a function called printf. And there's an alternate way to concatenate data with printf as opposed to using the chevrons, the insertion operator with the cout command. So we're using printf here to just put the message out to screen to prompt the user to tell them to enter a message. And then importantly, in the third line here, we're not using cin with the extraction operator, the 2 chevrons pointing towards a variable. But here, notice that we are using the getLine function, which is part of the cin library. And there's a reason for this, because with cin, that would terminate at a white space. So it's typically used to read in single words at a time. And you can actually have multiple variables set up to take one of the words that are typed in. So if we wanted to enter 3 separate words separated by a white space, then we could set up 3 variables and then put the cin statements next to them, one after another. So the 3 words would be separated into the 3 variables, each variable holding one of the words, entered in order, of course. But here, because we probably want to type in a sentence, a combination of words separated by white space, ideally we want to keep all these words together in the same sentence, in the same variable. Here we've set up an array, our char buffer. So we're using the get line so that it doesn't separate the sentence by the white spaces. I'll actually store them as an empty character to indicate the white space between the words. All right, so that's why we're using the get line function there. And we also had to specify where this message is going to be input into, which is the buffer, and then the size of that char array, which is 200 elements. All right, so that's the alternate forms of input and output that we're using here. Of course, they'll still achieve the same goals of inputting data and outputting data. We just have to format them slightly differently. Okay, that's why we're using these functions. All right, so let's go on to the send function here. And that's in the 4th line here, which is emboldened. And notice that we are passing the client socket, so we must be at the client end here, passing the pointer. We're passing the address of the character array, which is buffer, then the length of that, 200 elements, and then 0 for the flags. We don't want to change any of the settings, so we'll just pass 0 there. Okay, and then remember that the send function is going to return the number of bytes that have been sent, so just set up an integer variable to store that, the byte count, and then we've got the same type of validation taking place, where in the first if statement, we're comparing that byte count against socket error. So if it returns a value which corresponds with that, then we must have an error. And notice within that conditional statement, we're using the printf function, which has, as we said, has a slightly different way of formatting and concatenating data. So here, notice that we've got a placeholder within the string. So notice there, %LD, that will be the placeholder for the value which is returned from WSA get error, which you'll notice there comes after the comma. So I think the L stands for long in the reference and D for decimal. So basically we've got a capacity for a long value, which is significantly larger than an integer. And also D could hold decimals if it needs to. So presumably we're expecting some form of numerical value to be returned from WSA get error, corresponding to an error number, I presume. Okay, and then we can just include that in the statement, the error statement that's going to be printed to screen. And then we've got the same for the else statement. So assuming that the data was sent, in this case from the client to the server through the socket, then we just print out a positive statement to screen, and again using printf here, which is again inserting the value for byte count at the placeholder %LD within the statement. All right, just to affirm that we have sent this amount of data. Okay, so that's the send function. Now let's go on and have a look at how we receive that at the other end. So in this case, if the client is starting the conversation by sending from client to server, then at the server end, we'll need to start with the receive function, which is abbreviated to RECV, short for receive, at the server end. So therefore, at the client end, we would start with the order of sending using the send function and then receive. And then at the server end, we'd start the opposite way around with receive and then go to send, okay? Because these functions will block execution until data has been sent and received respectively. So we have to have them the opposite way round. There's going to be one machine which will send something to then be received. And then if it wants to respond, it can then send something back for it then to be received at the other end and then repeat the process if necessary. Okay, so at the server end, we would start with the receive function, which you'll notice here has an identical format to send. So we have the socket, the accepted socket. So at the server end, that will obviously be the accepted socket, and then a address of the character array, buffer in this case, then the length of the array as the third parameter, 200 again, and then optionally flags. And of course, we won't change the behavior here either. And again, like the send function, it returns the number of bytes received. So we're looking for a non-zero value to be returned to indicate that we have received data from the sending location. Let's have a look at an example here, which should be very similar to send. And here at the server end, we've set up a buffer to receive the data being sent. So basically that data in the buffer at the client end is going to be sent, and then we need to store that somewhere locally at the server end. So set up a character array, a local character array of the same size here of 200 elements to receive that data. Then in the second line, we've called the receive function, passed it the accept socket, receive buffer. So this is going to be the local end, which hopefully the receive function will copy this data being sent into. And then the length of the array, of course, because it's not a dynamic type, it's a primitive type. It doesn't have attributes associated with it like a complex type or a class would. So we need to specify how big this structure is. Say it's of 200 elements. And then 0, of course, for flags. All right. And then, of course, that will receive the data, hopefully copying it into receive buffer. And then it also returns a value to indicate whether that took place or not. So again, we're looking for a non-zero character. So anything less than 0 in this case must be an error. And then again, we use the formatting here to substitute the value that WSA get error will return into the placeholder, which again here is %LD. And then if something greater than 0 was received for the value of byte count, hopefully that means we've received the data. And notice here that the placeholder is different this time. And this is because we want to display the string that we received. So here, %S stands for string. So we want to display the data, the actual message that we received from receive buffer. So we're not working with integers or longs or decimals or any type of number formatting here. S is going to be replaced with the message which was received in receive buffer. So that's what we'll see printed to the screen. So that's sending and receiving. And so it's that way around for sending for the client and then receiving by the server. And then we need to repeat the process at the server end if we want to send a message back to the client. So then directly after the receive code at the server end, we need to have sending code, basically the same as what we did at the client initially. We want that underneath the receive fragment here at the server end, and then at the client end we want this fragment again underneath the send so that we can then send data from the server to the client. Okay, so I hope that makes sense. Let's now go on and have a look at sending objects. And so let's imagine that we created a class called data and wanted to create a static object of that. As you'll see in the first line of the blue boxes here, we've got a static object of the data class. And let's imagine it has several data members. We've only got one here in our example, but let's just assume we have multiple ones and we give them values. And then what we can do is we can cast the static object, and I presume it will work for dynamic objects as well. We can cast this object, the address of the object, to a char pointer, and then put that in place of the buffer, where we would usually send the char array, the message of letters and numbers possibly, to the receiving location. So we can convert the static object to a char pointer, and perform all the other duties with including the sockets that's going to be sent on. And the only other thing we also need to do is calculate the size of this structure. So as we specified the length of the chart array previously, we knew how many elements it contained. But here we can calculate this by using the size of command. And then notice, rather than the size of the object, which may or may not have initialized its data members, what we can do is we can actually pass the class, the structure of which this object is made of. So at least if we didn't have any values for the data members, it will at least make it of a size in which it can hold values for those data members. Okay, so those are the two unique things here. And yeah, we can then bundle up different values as data members and send them as an object. And then at the receiving end, we then create another static object of the data class. So presumably we have to have access to its definition. Maybe we have to define it in both the server and the client, unless we are referring to it elsewhere. And then the receive function will manage to convert back the data that was converted to char and then passed as a char. It will manage to cast that back to the format of the data class and store it within the local data object at the receiving end, so that we can refer to the data members and the member functions of that class through the static object data. So we're not limited to just a string message or a single value that we want to send in this parameter slot. We can pass multiple values bundled as an object. Okay, so that's transmitting objects. Just before we finish up this section on TCP and move on to UDP, let's just say a little bit more about some string functions that we can make use of, because there are lots of different functions out there which can manipulate strings and format strings. And we can make use of one of these string functions to get around the problem that we have with using char arrays. We can assign values for char arrays, as we see in the first blue box, where we declare the char array and then use the assignment operator to assign a message, a certain value for the char array. However, we can't subsequently use the assignment operator to overwrite the value, the message basically, stored within that char array in a later statement. Okay, but what we can do is we can use string copy, or there's actually an alternate version, a newer version as well that we can use, string copy underscore s, to later assign a value and then overwrite the previous value if there is one, or at least just initialize the buffer with the certain value. And here we see in the middle blue box that using the string copy underscore s function, passing the parameters of the char buffer and then followed by the string value that we want to assign, will later enable us to overwrite any previous values that have been assigned to the char buffer. And we can also make use of string len as well to work out the particular size of that char array. And there's also one last function to cover here, which is the string comp, or the string cmp function, which will take two parameters, takes two strings, and it will compare them to see if they have the same value or not. What it will do is it will return 0 if they are equal, but then if one is less than the other, it will return a value less than 0, a negative value, and if string 1 is greater than the second string, then it returns a value greater than 0. Now, I can only assume that it's referring to the ASCII equivalents, the numerical values for each of the letters on the keyboard. And the lowercase letters have different values to the uppercase letters. So I can only assume that it's comparing them on that basis to work out how much greater string 1 is than string 2, or whether string 1 is indeed less than string 2. So I can only assume that it's actually adding up the individual numerical values for each of the letters within the string or the character array, and then seeing what the total number is of that string or character array, and then comparing them against each other. All right, so here what we're doing in the blue box is we've got a conditional statement, and we've embedded the call to string comp within the comparison here. So we are checking whether the buffer the character array is comparable with the string password, all in uppercase. And I'd imagine it's case sensitive as well, so it might not work if we're using lower cases. So just something to bear in mind there. And if that returns 0, that comparison between the buffer and the string literal, then we can say with confidence that the strings are equal, they have the same value. However, if we don't have a value that's 0, then we could either, if we can interpret whether it's lesser or greater than and what that means, we might be able to put out another message for that. I guess that might be a bit difficult to compare and work out what that means in terms of words, whether they're lesser or greater than each other in terms of their numerical equivalence. But anyway, we can use this just to check whether the two strings are equal or not by comparing them against 0. So here, there's just some examples really of using some functions of the string library. There are many others as well for manipulating, formatting, splitting, comparing, returning subsets of strings. There's hundreds of different functions out there that we could make use of. Okay, so hopefully what you're seeing here is that actually the TCP connection and transmitting data via the TCP protocol isn't too difficult. We've actually just got to think a bit harder about the formatting of our message, whether it's in string format or character format, and allocating enough space to send that and in the desired format of the send to and receive from functions. So now that we've had a good look at TCP, let's now move on and have a look at the alternative transmission method, which is UDP. So in the second half of this lecture, we're going to talk about UDP, which is an alternative method to TCP, but still transfers data from one machine to another. And we've usually referred to UDP as User Datagram Protocol, but it does also go by the name of Universal Datagram Protocol. So if you see that name, it's referring to the same protocol as User Datagram Protocol, just an alternate name. But they both describe the fact that client and server don't maintain a constant connection. Whilst they may use a socket, this doesn't establish a connection. We're going to see in a moment that they don't use the accept or connect function in the server and client respectively. But what it does do is that it does allow the client and server to specify an IP and port number that they want to send data to and also receive data from that machine, the IP and port number specified. And so an advantage of using this method of transmission is that it does reduce the lag associated with establishing a connection. However, it's less secure and also less reliable, as there's no guarantee that the different packets used to split up your data will actually reach the destination, the intended machine that they were supposed to be sent to. So what you'll tend to find is that this is usually used in circumstances where it's not essential that data is received in its entirety. Or in other words, if data is regularly being sent on regular intervals, then it doesn't matter if one of those updates goes missing or is lost in transmission, because there's other updates to come very shortly. So you tend to find this is used in multiplayer games where data is broadcast, and if it's updated every few seconds or every second or even every few milliseconds, then one of those updates that just happen to go missing for whatever reason will soon be replaced and updated by a future update. So in order to use UDP to transmit data from server to client and client to server, we're going to have to make some changes to the way we set up the application on the client and the server. Now, the first step, if you remember, there were 7 steps for the server and 5 steps for the client. Now, the first step can be left unchanged. We're still going to load the DLL on both the client and server in order to make use of WinSock. However, when it comes to creating the socket, for both the client and the server in step 2, we're going to need to configure it to use UDP rather than TCP. If you remember, when we configured the socket when we used TCP, we used constants referring to the fact that we were going to select TCP. So therefore, we need to make use of constants referring to UDP this time in order to specify that the socket's going to make use of the user datagram protocol rather than TCP. And then there are also some changes to the next steps as well. Now, in step 3 of the server, we bound the socket to an address, and we only need to do this for the server, and that's still going to take place. But we don't need to listen out on that socket to listen for a connection coming from the client. So step 4 of the server and step 3 of the client won't take place, nor will we accept the incoming connection from the client on the server end. So neither will step 5 of the server. So instead, we're going to jump straight to the equivalent of step 6 for the server, which is sending and receiving, and then also step 4 of the client, which is also sending and receiving. And we'll take a look at the sendto function, which is the equivalent of send for TCP. And we'll also take a look at the equivalent to receive, or RCV, which was what we used for TCP. We're now going to use recvfrom for UDP. Okay, because of course, remember, there's no fixed connection. There's no established connection via the socket. We're not listening out and accepting and establishing a connection between client and server on a dedicated socket. Instead, we are just specifying the details of the machine that we want to send to, and then the machine that we want to receive from. Okay, so let's unpack this a bit more then. Let's have a look at how we can configure our socket to make use of the UDP protocol. And so here on the server end, when we create our socket and pass values for the 3 parameters, remember they're all integers and they all have constants referring to selection between UDP and TCP. The first parameter is where we specify that we want to refer to the address family for both TCP and UDP. So we still leave that as AF_INET. And then it's the next 2 parameters that we want to change. Rather than using constants referring to TCP, for the second parameter, we want to specify UDP. So we use the constant sock_dgram, short for datagram. And then for the third parameter, we specify IPproto_UDP rather than a constant referring to TCP. So now let's go on and have a look at the sendto function. Now that we've configured the socket to use UDP rather than TCP, and presumably bound the socket as well to the IP address and the port number of the machine, we don't have to change any of that. We can now move straight on to sending information. And to do that, we use the sendto function, where if you have a look at the parameter list, notice here we're still specifying a socket as the first parameter. Now, this socket is going to be bound to the IP address of the server. So there's no guarantee that this will be connected to a client. Okay, we've not established a connection between server and client. We've skipped all the steps that listen out for connections and then send connections and also accept connections. We are going to just use this socket as just a means of sending the information, basically representing this machine. Okay, so it's probably not going to be connected, but we still make use of the API, the socket low-level resources of the machine in order to then send via a network. Okay, so we do have to specify the socket first of all, and then in the second parameter, we have the char array. So we need to pass the address of this character array. And then the third parameter is the length, the size of that character array. And then flags is the fourth parameter. So we're not going to change that. Just write 0 there for the default settings. So you notice those three parameters are the same as the send function using TCP. Still have to send a message and put it in a char array to be able to send it. Okay, so those three parameters should be familiar. But then notice as the fifth parameter, we've got the sock ADDR structure again. So we have to pass a reference to the structure in which we define the details for the machine we want to send to. So this is where we hard code the IP and the port number of the machine that we intend to send to. And we bundle it up into this structure and then send the address of a variable of this structure. So that's the fifth parameter. And then also we've got the length of the structure as well. Again, a bit like the char array, because these are not dynamic structures, they're not classes which have attributes which will work out the size of this structure automatically. We have to do this. So we can either work this out, or if we know it, we can specify it hard-coded. And so if we specify all the right information and in the format that is required, and all goes as planned and no error occurs, then the sendto function returns the total number of bytes that were sent, just like the send function of TCP. So again, we're looking for a non-zero value to be returned to indicate that we did send information. However, if not, it's going to return -1, which we can then use to do some validation and error checking. Okay, so let's have a look at the code fragment now. And here you should see the sock ADDR structure at the top. So this is where we define a variable of that. We're defining the variable address and then assigning values for its attributes. So specify the address family, the IP address, which is the loopback address here, it's 127.0.0.1, and also the port number as well, using the htons function to address any byte adjustment that needs to be made. Passing the port number hard-coded here as well. We're not using a variable this time, just going to write it into the htons function. And so the variable of this structure, we're going to pass in as the sixth parameter to the sendto function. Also have to cast it to an older structure. So that's why we've got the sock ADDR struct there, as in the explicit cast next to that. So that's the backtrack and just look at the others. So the first parameter of sendto is the socket, which we assume was set up correctly when we created it. And then we got the buffer. So in the first line above send2, we're creating a just a character array and got a message send to the server. Let's assume this is the client and sending to the server. So that's the second parameter, which we pass in the message, and then work out the length. So here we're using string len this time. It's another function. That we looked at some of the functions associated with the string family, and we can calculate the length of this buffer, or we could just write 200 there, as we know it's of 200 elements. So that's the third parameter. Then the fourth parameter, 0, flags, we don't change any of that. Then we got the fifth parameter, which we spoke about previously. That's the sock ADDR structure, specifying the IP address and port number that we want to send to, and then using the size of function in the sixth parameter there to work out the size of this structure. So that's good. Okay, so if this goes well and we send this message to this address, then we're going to return the number of bytes sent. And if this is greater than 0, then that means we've sent some data. So therefore we trigger the else statement here. And we actually display what we sent as well. Sometimes we output how many bytes were sent, but here I think we're actually printing the details of the buffer, the char array, so we'll actually get the message being printed to the screen. But if the number of bytes returned from send2 corresponds with -1, which may possibly be the value of socket error, by the way, the constant, but maybe we're not referring to that as we're not majoring on the use of sockets. So maybe that's the reason why we're not comparing with socket error. But anyway, if it's -1, we output the usual error message and perform cleanup duties. Okay, so quite a lot of information that we're packing into this sendto function. We're sort of combining the socket with the message being sent with the IP and port details to send to. So we're doing an awful lot of separate steps, which we would usually do individually with TCP. We're doing them all together with UDP. Okay, so let's have a look at the recvfrom function now, which, as you can see here, follows a very similar format. We've got the socket here as the first parameter. Then we've got the char array, the length of the array, flags, which we're not going to change. And then we've got the sock address structure. So this will contain the IP and port number, which we want to receive from. So here we're probably specifying that we only want to receive messages from this specific machine. So we can be specific with recvfrom, and it's actually a blocking function as well. So it will block execution until it receives data from this specified machine. And then finally, the sixth parameter, of course, is the length of the structure. Okay, so recvfrom returns number of bytes, as did sendto. So again, usual format, returns number of bytes. So if that's positive, then we have received data. But if that's -1, then obviously an error must have occurred. So let's just have a look at the code fragment here. Here we've got the client address being specified. So maybe we were sending from the server then, if we've got the client address that we're intending to receive from. Let's just say, anyway, it doesn't really matter which way around it is, but here we're just going to have to specify an address that we want to receive from. Okay, which we've done here. We've specified the variable of the sock addr_in structure. Also set up a buffer to capture this message as well. That's what the recvfrom is going to put the message into. So we need to specify that in the second parameter of recvfrom. We've also got a socket specified here in the first parameter, which may refer to the server if we're receiving from a client. So this may further say that we're at the server end. And then we've just got the size of the structures. We've got the size of the buffer here in the third parameter. No flags, fourth parameter. The client address, that's the variable of the sock address structure. We're casting that as we usually do. It's the fifth parameter. And then the sixth parameter here, we've got the length of it, okay, which we've also worked out. All right, so that's going well. Hopefully we'll return the number of bytes received. So we haven't actually printed out here, but maybe we could just print that out. It'd be good to see it if we're receiving a message, unless we don't need to display it. But here we've just got a check to see that if it's less than 0, if it's -1, then obviously we've got an error. So do the usual cleanup duties and print out a message. Okay, so that is sending and receiving via UDP. Great, so we've now covered how to send messages in the form of a char array through the UDP protocol using sendto and recvfrom. But now let's go on to how we can send complex types, and specifically look at how we can send objects of classes through the UDP protocol. And let's take this class here, for example, which I think relates to the exercises corresponding with UDP. And here we've got a class definition for vector 3D. So as it's 3D, it's going to have 3 points. And you'll see here we've got data members for X, Y, and Z coordinates. These are built as float types. And we've just got a non-default constructor that assigns the values passed in to the data members. Okay, so let's say that we wanted to send an object of this class through the UDP sendto function. What we've got to do is we've got to convert this to a char array. Now, remember in UDP, we actually casted the pointer first to actually send it, and then it did its magic of actually translating that into a char type, and then we casted it back at the receiving end. But here we're going to cast it ourselves. We've got a function which can do this for us. We've got sprintf here, which takes the char array, the destination array, what it's supposed to be converted to in order to send it as part of the sendto function. So notice here we've created a char array position buffer of 200 elements. 0 to 199, and that's going to be the first parameter here. And then we've got a series of formatting, and here, a bit like the printf function, we're going to use some placeholders like we did with printf when we output some messages to the screen. So we're going to substitute our X, Y, and Z values for these placeholders, which we see after the first comma after the position buffer. So here we've got a little bit more formatting. We've got percentage 6.1f, and then that's repeated 2 other times as well for the other 2 for Y and Z. Okay, so that percentage 6.1f refers to a single attributes, a data member of the class. So X, Y, and Z were our data members, therefore those will be put in place of those placeholders, and presumably bundled into the array and stored within the array in a special location that can then be reinterpreted and reused at the other side. Okay, so only one thing to note really is that the percentage 6.f, the 6.1 refers to the size in decimal places, and f here is referring to float. Like we could write d for decimal as we've done previously, we're writing f for float here to refer to the type. All right, so this is a more manual way of putting those data members of a class within the char array. We have to do that manually here for the sendto function, whereas with the TCP sending objects, we could manage to cast the address of a particular object to a char type, and then it translates it at the other end. Okay, so that's just an example here. What we'll do, now that we've covered UDP and also TCP at the start, let's now move on to have a look at how we can implement this in our code and extend what we did last week to be able to send messages back and forth from the client and server. Great, so let's have a go at the exercises for this week. And the great news is that we can continue from where we left off from the previous week. In week 11, we set up the server, the first 5 steps of the server, which would establish a connection with the client. And we programmed the first 3 steps for the client. So this week, we're going to have a go at using the TCP protocol to send data back and forth from the server and client. So this works out to be step 4 on the client and step 6 on the server. So the first exercise of the TCP document, great news is that we can continue from the projects that we set up last week. So you can just reuse the code. You can do it in the same solutions if you want to for the server and the client, or if you want to create dedicated ones. If you're going to do that though, remember to include the necessary library files, the stdfx and target version. Copy them in from the previous week, and do remember to include the dependency to the ws2_32.lib in your project dependencies. But if you're going to use the same project files and solution files that you created last week, this should still be set up for you. All right, so let's dive in then, and we've done the first part of exercise 1 because we've got the projects from last week. So let's start with the client, which is part 2 of exercise 1. And let's add the code to allow the user to type in a message, and then we're going to send it. All right, so we left off at step 3 of the client last week. And what I'll do, just a little bit of organization. is, let's say this is step 4, and we are going to chat to the server. Okay. And I'll tell you what, we can also use the system pause and WSA cleanup as part of step 5, which is to close the socket and also disconnect the resources. So let's just say close socket. All right, that's what WSA cleanup will do for us. So really, it's just step 4 that we need to code for the clients. This should be at the end of step 3, so just move that down under here. You don't want to disconnect the socket before you start sending. You need to make sure WSA cleanup comes last. All right, so just remember that. And when it comes to sending, remember we need to use the send function of the WinSock API. And remember that takes 4 parameters. Takes the sockets. So at the client side, we should have a local variable, which is client sockets. So let's use that as the first parameter there. And then we want to pass the address of a char array, character array. So let's set that up. I'm going to do that above. So let's say char buffer. And we used 200 last time. That should be plenty for what we need to do. And then we want to include that as the second parameter. And then the length is 200. That's the number of elements there. And then flags, we left at 0. We left that at the default behavior. We didn't change any of that. So just type 0 for the 4th parameter there. And we also need to provide a message. So let's tell you what, let's get that from the keyboard. And I think that's what we're asking here anyway, to allow the user to type in a message. I think we predefined one in the slides, but let's add one in here. So let's say we first of all output a message to the user, say, please enter a message to send to the server. All right, I can go there. And then we want to assign what they type in from the keyboard into the buffer. And remember, there's a special function that we're going to use for this. We're not going to use cin directly. We're going to use cin.getLine. Oh, that's lowercase there. GetLine. And because remember, that will capture the entire line, including white spaces. Cin only works for up until you have a white space. So remember to use getLine to capture sentences from the keyboard. And we've got to specify 2 parameters. We want the char str, which must be the buffer, that must be the destination where it's going. And the second one is the count. I presume that's the size. So let's type in 200 there. That should be what it's looking for. So that will capture what we type in on the keyboard and put that into the buffer. And then that gets sent in the send function. And then remember, the send function also returns a value. So that returns the number of bytes which have been sent, hopefully. So we need to test this. We need to say, well, if byte count is greater than 0, then we must have sent some data. So let's just have a little confirmation here to say message sent. And I'll tell you what, let's include that message as well, just so we get another confirmation there. There we go. And in the other case, of course, we could clean up. So let's just say WSA cleanup there. Copy that. Also, we could put another message as well, but I'll leave that for now. Okay, so that should go through to the server. So that's the sending part. Now I think we need to code the server to receive this. So here we go. I've got my server loaded at this end. And let's do a very similar layout here. I'm going to just do a little bit of formatting. I'm going to use system pause and WSA cleanup. Now this is step 7 in the sequence of events in the server. And let's make some space for step 6, which corresponds with step 4 of the client. Because remember, in the server, we had a few more steps to do with listening out on the socket and also then accepting the connection. So this is going to be step 6, chat to the client. All right, so we've used the send function at the client end. So therefore, at the server end, we need to use the receive function. All right, and we'll need a buffer as well to capture this, just in case we need to see it on the screen. So let's copy that into here. We're not going to send a message just yet. I think that's coming up in exercise 2. But what we will want to do is use very similar details, but I think we just modify this to say RECV, short for receive, and then rather than client sockets, we'll just say accept socket, because remember, the server creates a dedicated socket so that it can keep listening out on the original one. All right, the duplicate of it will be the defined connection, the established connection between the client and the server. All right, so different name at the server end. And then let's use this as well. So receive also returns byte counts, and we'll say, rather than message sent, we'll say message received. And hopefully that was captured in the buffer there. And if not, let's clean up. Okay, so I think that should be enough to get a message sent from the client to the server. Let's just pause here and check that we can run okay without issues. So I'm just going to load the server up. And let's also get the client fired up as well. So here's the server, waiting for the client. Hopefully it will load in time. There we go. Smaller. Yeah, accepted connection. And yeah, so we're currently waiting at the server end for a message. So let's just say, hi server. And there we go. We've got a confirmation at the client end that we sent it, and also a confirmation at the server end to say we received it. That's good. And then we're just closing the socket to exit. Great. So we've got it one way. We've got from the client to the server. So I think the next exercise, exercise 2, just takes it a bit further. Let's just get out of this. And we then... we actually send back a confirmation. So let's just check this. Yeah, exercise 2. So we can send a receipt back. It's an automated receipt. Assuming that this went through okay, we now want to send a message back from the server. Oops, I need to go to this side, sorry. And so server received first, so then it needs to send, and then the client's going to be around. It's sent first, so then it needs to receive. Okay, so let's invoke send at the server end. So this is still going to be on the accept socket at the server end. And so the buffer is where our automated message is going to go. So tell you what, let's set up a new char array dedicated to our confirmation. Perhaps we'll want to use the buffer for something else. I suppose we could store it in buffer temporarily, but I'll tell you what, just to keep things separate, let's just have this automated message here. Say message received. There we go. We've got a dedicated char array for that. So that's going to be confirmation. There we send that. Oh, sorry, we put that in the send function. It's of 200 length and again 0 flags. We're not going to change any of that. So that's at the server end. And so again, that also will return a byte count. So let's just update byte count. And let's also have a very similar conditional block here to say, well, not message received this time, but message sent. Maybe we could just say automated message. automated message sent to the client. Automated receipt, whatever you prefer. And I don't need to, let's not worry about the buffer because we know what that is. Okay, so that should be the server end. Let's receive this message at the client end now. So switching to the client project, we now need to receive. So let's see if we can reuse some of this. So don't need to redefine byte count. Instead, we'll just overwrite it. Let's change send to recv. It's still going to be on the client socket. That's the dedicated socket. Just the handle for it at this end is client socket, local to this project. Buffer, I think it can it should be able to receive it, a buffer. Hopefully it overwrite the message which was sent. We can put that to the test. We'll find out. Still have 200 and 0. Yeah, for the flag. So I'll tell you what, let's see if we can overwrite the message that we originally sent and reuse that buffer. So again, if the byte count's greater than 0, we received the message. And buffer, yeah, let's hope it will overwrite that. Hopefully receive will take care of that for us. So let's now put this to the test again. I think we've got everything we need. So let's give it a try. Let's see if we can get that automated message back. So I'm going to load the server first and then load the client. So server. And nice and quickly, let's pop that this side, and then the server's just, the client's just loading. Everything in good time. Okay, so first of all, we need to send a message from the client. Let's just say hi server again. And so there we go, we've got that automated message being sent. Great, so backtracking, we initially sent a message which we typed in from the client to the server. There it is, hi server at that end, and then we just got a confirmation this end, and then the server automatically sent back a receipt which we received and then displayed and then closed the sockets. Great, okay, that's good news. So I think now you guys are in a good position to have a go at the remaining exercises. So see now if you can extend this further in exercise 3 to get a constant chat going. See if you can send messages back and forth and keep the conversation going. So see if you can find a way to loop that functionality in the server and the client until one of them decides to exit via a keyword, shutdown in this case. All right, and then if you want to take it further as well, try using threading, which we had a look at in a few weeks ago, and see if you can get a dedicated thread for your listening sockets. Great, so give that a go and see how you get on.